Together we are going to see how we can exploit the given script in order to simplify the entire pipeline from searching, downloading, and pre-processing Sentinel data. Before I start, I have to make here a slight introduction to our application, the initial module of this pipeline, which is the Umbrella Sentinel point. What is Umbrella Sentinel point? First of all, you may have found yourselves searching and harvesting metadata and data from several hubs. There's the Open Access Hub, there's the DIAS platforms, there are the Google Earth Engine, there are multiple hubs where you can go and try to find out some Sentinel data. But there is a complicated process. This is a complicated process because several times we cannot find the data we are asking for. The reasons behind this lack of data is that many hubs does not have global coverage. They do not provide worldwide data, or they are not providing the entire Sentinel missions, 1, 2, 3, and 5. In addition, there's a data rolling policy that's important and crucial to our search. A high number of hubs delete their data after some times. For example, they delete their data after 30 days or after 6 months. This is very annoying for the users because they go and try to access the data and they cannot find online data. They only can find offline data. They request this data and the data came back to them after some minutes or some hours. Moreover, many hubs are under maintenance in order to update their servers and their systems. And last but not least, there are performance issues in specific hubs that they serve many people and many users. Thus, we have developed a certain application which connects to many hubs, currently 10 of them, and harvest all the metadata in order to have the complete collection of Sentinel data. But except from this, the Umbrella Sentinel point provide users not only the metadata, the Sentinel metadata, but the best source, the most efficient source to download from at any given instance. So if you ask for a specific time series of Sentinel-2 data, you may get it from the Open Access Hub now, but in 1 hour, the Umbrella Sentinel point may say to you that the same time series is better to download from another hub. How this happens? Umbrella Sentinel point tries to get a score from its hub based on availability and download speed, and give a certain score, a certain ranking to each of this hub. So every 15 minutes, the hubs are getting a score in order Umbrella to provide the most efficient hub at any given time instance. This is the idea behind the Umbrella Sentinel point. And now, if you have any questions at this first stage, I mean, to be a little bit interactive, and please interrupt me if you have any questions during my presentation. To conclude this introduction, we can say that Umbrella Sentinel point is a smart broker of Sentinel data. So let's get hands-on to see how we can exploit the scripts. But first, in order to exploit these scripts, we have to create an environment. I don't know if you are familiar with creating virtual environment. A virtual environment is a dedicated environment to install libraries and frameworks and softwares in order not to have conflicts with other existing libraries. In order to avoid this, we can create, based on software Anaconda or Miniconda, a virtual environment. How can we do it? let me start from the beginning. We can make conda, which is the basic command in order to use anaconda or mini conda. Conda create -- name. All these instructions have to say that they are in the README file. So I'm just executing now the commands that the instructions that you have already in a README file. Conda create name. This is the name of the virtual environment. For example, EIFFEL env. And I can also set the version of the Python that I'm going to use. It is strongly recommended to use 3.7 higher version of Python. So if I execute this command, I will have a new virtual environment that is called EIFFEL environment, and which will include the Python programming language in version 3.8. Oh, I'm sorry.
Hi, Thanasis.
Yes.
I'm wondering what you point to have a virtual environment.
I cannot hear you very well. I don't know if the other can hear you. Please repeat if
What
you
is
can.
the point to create a virtual environment?
Okay, this is a good question. I have also mentioned the advantages. I will say it once more. If you have many libraries in your system, they may conflict to each other. So in order to have a clean space to create something new, you can create a virtual environment to install there all the necessary environments, because it is very frequent one environment or the same library with different version to conflict with another one. Okay, so it's better to have a clean space, a clean storage to install all your libraries there. And when you are inside this virtual environment, you are only using the libraries that have been installed there. Because many times when we install libraries in a common storage, we have installed, for example, 3 versions of Python, and you cannot know which is running behind, Python 3.7 or Python 3.8. Now that you have a dedicated virtual environment, it is only connected to this specific Python and to the other libraries I will install.
Yes,
Is it clear?
Yes, thank you so much.
Okay, great. You're very welcome. So I lost, sorry. I have this Zoom bar and I cannot see where I, so. When I press the command, you can see that it says to me, do you want to proceed with these installations? Because one library can include other sub-libraries or some relations. Of course, I say yes, and I'm starting to install my virtual environment. Okay, this is now installed, but it is not enabled. In order to enable it, I'm gonna use always conda in front of every command, then activate and the name of the environment. So it's EIFFEL env. And now you can see that in the left side of the terminal, I'm in a terminal, I forgot to say that one. I'm here in Ubuntu 20.04, and I'm using a terminal, a single terminal to execute a series of commands. So you can see that it is now activated. In order to get out of this environment, you are writing conda deactivate, and then you are out of this environment. So now I have activated my environment, and I'm going to install all the other necessary libraries. Let's see what necessary libraries I'm going to have. The first one is GDAL. GDAL is a very popular geospatial processing library. It is based on C language, and that's why it's a very fast processing library for geospatial data. I strongly recommend to use this one. There are also other libraries which may seem, and they are simpler for using them, but GDAL is a very fast library regarding the geospatial data. So again, conda install. Now I'm inside my environment and I install all the required libraries. So let's give it a moment. In the same way, we are going to install all the needed libraries that are inside the requirements txt file that is that has been sent to you. Okay. So you can see that it takes some seconds. Okay, so now it's installed. In order to see if something is installed properly, you can use Python. You can write Python, and you when you write Python, you are inside a special editor terminal, which is about Python. Here you can write commands related to Python. So in order to see if GDAL is installed, I can write from osgeo import GDAL. And you can see that there is no error. That means that it has been installed properly. You may wondering what is OSGeo. We called here, we installed the library GDAL, but the official name inside the Python is OSGeo. So this is a tricky part, but you can always Google it and find things. You will never have to worry about this because we have already implemented code and the imports and things like that. What does the import mean? It means that I'm going to use all the modules, all the functions of GDAL. Now have loaded all the functions of GDAL in my code. If you not make the import call, it cannot use the GDAL or any other function that you want to include in your code. So import means allow me to give you all the modules, all the functions that you need inside your code. I'm getting out of Python code. I wanted to just show you to showcase that the GDAL library is installed properly. And now I can install all the other libraries. For example, conda install NumPy or conda install pandas. I'm not going to install this one because I have already two similar environments in order not to load my storage in this machine. So I'm going to deactivate from this environment and activate the similar environment that I have already created. Okay, this is the one. I repeat, I stopped installing in the previous environment in order not to take more space, more storage, because I already have another similar environment. So I have to mention here, I have to highlight that there is a specific library that you are not going to install via conda, this command, and this is the snap library. The snap library is based on the ISA snap software, which is a software for pre-processing, especially SAR data, Sentinel-1 data. There is a very tricky installation of the snap library, which is which has been analyzed in detail in your documents, in the README documents, and I have also added there some errors that you may occur based on your machine. So please try to install it based on the tutorial that I have sent you. But in any case, if you find some difficulties, please contact us to give you some guidelines. It's generally a tricky library to install. It has many issues. there is no point to show you how we installed it now, because you may find errors depending on your machine, different on each of you. So give a try firstly, and then if you have any issues, we are going to discuss it together, synchronous or via synchronous ways. Let's move on to our scripts.
Sorry, what was the name of this library again?
There is the snap. It is written snap, or you can see it snappi.
Okay, thank you.
This is the tricky one. You will see the tutorial. I mentioned with details that it's a tricky one and you may have errors. I think it's the number 3 on the README, if I remember well.
Okay, thanks.
Now, let's start. We can use Jupyter notebooks in order to write some text also and to present you in a more friendly way what we are going to do. Jupyter Notebook is a Python editor where you can write and execute Python code, but at the same time you can use HTML code in order to give a format to your text. You can see here that there is a formatted text, and to write notes. This is the Jupyter Notebook. You may many of you have you may have used it before. So first of all, we are going to see here how we are going to search via the Umbrella Sentinel access point metadata for our purposes, and then how we are going to download. I repeat that the Umbrella does not hold the actual products. It does hold the metadata of these products. The products are going to be downloaded directly from the sources, from the hubs, not from the Umbrella. So let me restart my kernel and clear all the output in order to be clear. I execute the first one. This is called cell. I execute the first one, and you can see that I loaded all the necessary libraries. And then we are starting to, we are going to query the Umbrella in order to give us all the necessary metadata. In order to query the Umbrella, we have to set some parameters. There are some generic parameters independent from the Sentinel mission. I don't care if it's 1, 2, 3, or 5. And this is the B box. This is the bounded box. This is the X min, X max, C min, and Y min and Y max. These are the coordinates of the bounded box, the 4 corners. This is the start, the area of interest, we can say. This is a starting date, the starting session date, and the ending date. This is the time range you want to search for which you want to search products. And the product type, which is different based on the mission. For example, you have GRD or SLC for the level for the Sentinel 1. You have MSI level 2A or level 1C for the Sentinel 2, etc. You are not prompt. There is no obligation to use all of them, but I strongly recommend to use the big box. This is a very important parameter in order to minimize also the time complexity of the searching process. This is an area of Cyprus here that I have set. And let's go now to the additional parameters based on every mission. We have additional parameters at this time of speaking for Sentinel 1 and Sentinel 2. Which is the polarization and the sensor operational mode. I have set 2 values. Of course, there are not only these 2 values. You have a series of values based on what you want to search for. And for the Sentinel 2, it's the max cloud coverage and the tile name. Okay. Yes, Claudia?
Hi, I was just wondering, with the B box, should we change the coordinates according to our pilot?
Yes, exactly.
Okay, and also the start date of our interest, I guess.
That's why they are called parameters, because I have set them here in the beginning in order you to change it according to your needs. This is the idea.
Okay, thanks.
So this is the additional
One question,
parameter you can.
Thanasis.
Yes, I'm sorry.
Sorry, in the general parameters, once you have start date and end date, obviously if you are working in days, it would be no problem, also in years. But if you work in days or in hours, you need to have a time zone, right? In order to be sure when did this scan start and end. Otherwise, you may confuse the data, right?
Yes, that's why you can use a buffer zone in order to be sure, because now they are saved into our databases in set time. Okay, so if you want to be sure, you can include one previous day and one after, and 1 day after your final date in order to download the products, and you may delete the one you need, but we can change it. We can update our code in order to include also a time zone and of course the time. We can do it.
Okay, it was just a suggestion, just to know if we need to make this post process after just getting the data, just deleting the irrelevant hours.
Yes, we can do it. You can do it. It's open. We can put additional parameters like the time zone, but the easiest way now is to download, to search, to find the products, and then from this search process to exclude the one that you do not need, that they do not fall into your desired time range, daytime range.
Okay, thank you.
Thank you too. Okay, I move on. The polarizations. I repeat that you can. There's no obligation to use all of them. You just keep the things that you want. And now let's see how a query is created. As you can see, there is the base link, which is up to here for the Umbrella application, from the Umbrella API. And there are 4 endpoints, 4 different folders, let's say. Sentinel 1, Sentinel 2, Sentinel 3, and Sentinel 5. So based on your needs, you are choosing every time the endpoint that you want. For example, here I have Sentinel 2. And then you construct the URL based on the parameters. For example, here I have identifier contains level 2 products, and the inbox, this is how the Umbrella is calling the bounding box. It is calling inbox. The names of these parameters can be found in the official site of the Umbrella. There is a documentation on how we call this parameter, identifier, inbox. If you go, I'm sorry, I'm not in my machine, I'm in another machine remote, so the analysis is not so good. You can see that there is sensing date, and this means greater than equal from the one you set from the parameter before, and sensing date less than equal than. This is there is a range from this one to that one. Okay, I repeat, in order to be clear, these names, identifier, inbox, sensing date, is always the same. They are how the Umbrella name its parameter, its filters. And here we set the parameters that are given above. This is our needs. The B box we said before, the start date we said before, the end date we said before, and of course here it's hard coded, but I can also put it as a parameter. For example, product type, because I have a parameter before that it says product type here. Okay, so I put it product type. This URL now, it's filtering our database, and what happens is that it creates a CSV file that holds all the necessary URLs to download from. Okay, they are all stored in a CSV file. This is a simple procedure and a simple approach, because you can, if you experiment with this, you can save the results of the umbrella query to a database. And why to a database? In order to have the full control of what is going on and to make, I don't know, for example, special queries based on the extent of the products that are found from the umbrella. But before we discuss this one, let's see what is going on. Let's see what's happening. If I run this code, okay, you can see that it has found 5 products. Okay, it has found 5 products, and it has saved these 5 products into this CSV. Let's go and see the 5 products.
Excuse me, Tanas.
Yes.
At which stage we specify the end date?
I'm sorry.
I'm really sorry. I think that my internet is not like so good. My question is related to in which stage we specify the end date, because we have all just specified. Okay, sorry.
It's
Okay.
end date.
Okay,
Sorry
good.
if I going too fast. Please hold me on and make questions, because I try to be to go slow, but in many cases I found myself in a hurry. So
No,
please.
no, it's okay. It's just like my internet, so I'm like skipping some parts of the Jupyter, so I can see all the things. So yeah,
Okay,
it's my fault.
okay.
Thank you.
No worries. I will repeat many times. Yes.
Hi, I'm Stelios from EIFFEL. I want to ask you something. Do we need to define or determine the CRS for our coordinates, or I don't know, because you just put some bounding box without CRS, so I'm just wondering.
Stelios, thank you very much for your questions, because I totally forgot it to say that the B-box here is in the most frequent projection system, 4326. Okay.
Okay.
We are generally working in the pseudo Mercator, which is 3857, but for this specific module, for the searching process, because this is the most common, we strongly recommend to use this one. Okay.
So if I'm using some other CRS product, what can I do with this bounding box?
I will recommend a very good site, which is the B-box Finder.
Yes,
that
okay.
You can convert it. Otherwise, if you have, you are free also to code and to write 2 lines of code in order to convert one CRS to another.
Yes, for sure. I was just wondering with this B-box if I could fit my coordinates.
Okay, yes. We have not taken into consideration that someone will give another CRS. We say to the users, just use 4326. Of course, this could be an extension later on to put your CRS and to convert the user CRS to this one. Okay.
Okay, thank you so much, Thanasis.
Thank you also. Let's go on. Let's move on. First of all, to see what has happened. If I'm going here and open the product to download the file that has been created 3 minutes ago, you can see that this is the identifier, the unique name of the product, and the source. This is the URL from which I will download my product. Okay. As we said before, Umbrella does not store the actual products. It stores the metadata, so it gives you back the metadata and the most efficient hub now to download from. This means that in, I don't know, in 1 hour, the OpenAx hub, the Sci hub, it may not be here. For the same product, it may say something else here, another source. We have 10 sources that we are connected to right now. Okay, it may say PEPS from France, or you may say the Hellenic Mirror site, okay, or the Austrian hub. It may say one of the 10 every time. Okay, and this is a tricky part in the download process. This is currently a disadvantage of the Umbrella, I think, but it is something that we cannot avoid based on our architecture. I will analyze this to you in 2 minutes. Back to the download process. And now, this is the time that I have to analyze you what I was talking about. So Umbrella is connected to these 10 hubs that you can see here. But when you are trying to download the product, you have to be an authenticated user. You have to have registered to these 10 sites, to 10 hubs, because the Umbrella every time can provide you a link from a different source, from the PEPs or from the OnTADIAS. In order to download the products from this specific hub, you credentials have credentials. So my opinion is to create credentials in all of them, but to use every time the same username, the same password. This is the most efficient way to avoid changing the code. If you use the same one, there's no matter if you download from the OnDAR, download from the Finnish mirror site or the Norway call hub. Okay, so I recommend to create the same username, the same password. And here I have created a file, a JSON file in a secure folder without permission from external user to open it. And I load my username and my password that I use in order to download the products. How I'm going to download the product? I set here the directory that they are going to be stored on my machine. And I also read the file that I created before in order to take the links and starting download. Before I go on, I have to mention here that you can see some functions, some ready-to-go commands that download products, for example. And before the find products, these two commands are not ready-to-go commands from a library that we have installed. They are, we have created a utilities .py file that have implemented some functions, but because this function contain a lot of code, many series, many rows of code, we have hidden, we have hide them from you in order to simplify your life and to use instantly the function. So in order to write here all the code about the find products, we have put it in another file and we just import the function from the other file. So it is easier for a user to write find products instead of see all the code that is behind this command. In that direction, download products is also a function that is included in this file here. And if you want, you can parameterize also this file in order to change something that do not fit to you. But for a simple user, I recommend not to not to update this file. Let's try to download the files now. I have created the CSV, which says what file to download, and I have set also the working directory in order to download the needed file. I execute the code, so you can see that it is running, but if I go inside the directory, you can see that a file has been created. The first file, there is a certain structure on how the download products are getting into my directories, into my storage. First of all, the download product creates a file that says the year. If you go inside, the next file is the tile name, because we are downloading Sentinel 2. If we download Sentinel 1, it says the relative or the absolute orbit number. So this is a different structure. For the Sentinel 2 only, it's a tile name, the second folder, while for the other Sentinels missions, it's a relative, the absolute orbit number. If I go inside this folder, I can see that this is the month here, February, okay? And if I go inside, you can see that it has already downloaded very fast these 5 products. Okay, so the download products makes the following process: creates a certain structure in my desired directory. It creates an initial folder that says the year from which we download the product. Then it comes the tile name for the Sentinel 2 and the absolute orbit number for the other Sentinel mission. Next step is to create a folder with a month, and inside this folder we have the actual products in a zip format. Okay, any question up to here? This is not always good.
Claudia, is your hand raised from before?
No, sorry, I think it's from before.
Okay. So we are here. We have downloaded our products in a zip format, and many times we wish not to be in zip format because we have to unzip it, and this is a boring process. That's why the next cell here unzip automatically all the files in the directory that is been chosen by the user, and also removes the zipped files. So if I run this one now, you are seeing the logs here that starting to extracting from the zip files the actual files. And if I go here, you can see that there are folders and the zip files are gradually being removed. Now we are ready. We have our products in folder format, let's say, with the extension .save, and this is something now frequent for you to see. It's the structure of the save file for Sentinel 2. Okay, and here is the end of the first step, which is the searching process and the downloading process of the Sentinel products via the Umbrella API. To conclude here, I will repeat that the Umbrella does identify the metadata and the most efficient hub to download from. If you want to skip it, you can skip this step and search in a dedicated hub if you wish. But it does not, we do not care about the first step. I mean, both Umbrella and dedicated hub can lead us to the second step, which is the download process, which is independent of the first step. I'm sorry. I mean, the download process here is something that can stand up alone. It's independent from the previous one. Okay, you can have a dedicated hub here to get the data, to get the metadata and the links, and then this one downloads the links. Of course, if you have credentials from the chosen API or from all the APIs that the Umbrella is connected to. Let's see some problems that they may come up here.
I have a small question.
Yes, of course.
These credentials, is it easy to get them? Do you need to just make an account on all of the sites, or how do you do that?
Yes, there is a graphical interface in all of the sites, and it's quite easy to make a registration.
Okay, so it's easy. Okay, thanks.
It's easy, yes. I have to mention here and highlight some issues, some problems we're trying to tackle, but it's not always related to our site. I mentioned before the data rolling policy. This means that the data become offline after a certain period, which is different on each hub. I mean, for example, the open access hub may have a rolling archive period of 1 year. This means that the products from July 2021 and back, they are not deleted, they are getting offline. There are other hubs that also delete and also making offline the products. So Umbrella has to deal with this. The Umbrella every 15 minutes tries to find out if a product is deleted. And based on the documentation of each hub, it makes also the products offline by deleting from the database. So if a product becomes offline in the hub A, it is being deleted from our database. We do not provide offline products. We also provide online products, but pay attention here that because you may have problem with this. If the hub A says in the documentation, I make all the product 1 year and back offline, the Umbrella goes 1 year back, but the hub A may not make only 1 year and back offline products. It may change the products to offline from 10 months and back. I mean that the rolling archive period is not a strict period. They say 1 year, but they may be 11 months or 11 and a half months or 10 months. So this is a problem because we have a buffer zone. We have a small amount of products that we say that they are online, but they are not online. Actually, they are offline because they do not. The hubs didn't follow the rolling policy period they mentioned in their documentation. This is something that we cannot deal with the existing infrastructure, because another alternative would be to check all the products in all hubs to check if they are offline or online, but this is of high complexity. We cannot make this with a current infrastructure. And I think it's silly to check all the hubs to check if they're offline or online. In simple words, in simple terms, you may, what is the effect on you? You are going to download the product. And if the product is offline and the umbrella says it's online, then you will see that a file has been created in your storage, but this file is 0 kilobytes, is of size 0. That means that it couldn't download for some reasons the product. And the most probable reason is that the product has become offline and the umbrella has not turned it offline due to the reasons we said before. Any question here? Let's go to part 2, which is the pre-processing of Sentinel-2 products. I will start with Sentinel-2 and then I will move to Sentinel-1, which is a more complicated pre-process pipeline. So the Sentinel-2 products come in a certain format, which is a JP2 format. This is a usual format. You can work with this format, but many times you need to make some pre-processing steps in order to generate more efficient formats like the GeoTIFFs. The GeoTIFFs is an image format which is far better to work with. That's why we have embedded also this kind of steps. So what we are doing here is to apply some pre-process steps, which are the reprojection. We are reprojecting to the 3857, which is the pseudo Mercator, because this kind of format is very friendly to the browsers. When you are developing web applications and web maps, this is a very friendly format to projection to work with. We also resampling the bands of 20 and 60 meters to 10 meters, but this is a pseudo resampling. We are using the nearest neighbor and we copy the values of a cell. We split a cell to 4 and we copy the values of the initial cell. So it's a pseudo resampling. And we create cloud optimized GeoTIFFs, which is a new format of GeoTIFF, very light regarding the size of the file. All of them are based on the GDAL library I mentioned on the beginning. And let's see how we are going to make this happen. Like before, we are loading from the utilities file to functions that we have implemented. And now the required parameters are only 2. It's the repository we have saved the raw data, the actual data, and the out directory, the output directory, where we will store the generated files. Before I start, let's show you, if someone has not seen, how the structure of a Sentinel-2 images. You can see many files here. All of them have some less or more important informations. We are currently working with this one, which goes inside. And here we have the images, the different bands here that comes in several resolutions, 10 meters, 20 meters, 60 meters. If I go here, you can see that we have, this is the basic bands and the RGB, the true color, okay, image. And if you go to the 20 meters, you have additional bands. This is an important one. This is called the scene classification band, and it has make the ISA, the pre-process, a first pre-process of ISA is to create a classification map on which each pixel is assigned to a specific value. For example, there is the probability of a pixel to be water, or this is the probability of a pixel to be agriculture or to be cloud. Okay, here we have a raster, we have an image I'll have a file that has the class of each pixel based to a certain algorithm. Okay, this has been generated by a software that's called Sentinel, and it makes an atmospheric correction and also creates this scene classification mask. I repeat, every pixel has a specific value here, which represent in which class it belongs. For example, agriculture. For example, shadow. For example, cloud. It's snow, etc.
Anasis,
Yes,
can I ask you a question
of
about
course.
this part of the scene classification?
Yes.
You said that it's already classified every pixel according to their form. If it's a rural area, for example, or cloud and stuff like that. Is this in this part high accuracy? That I mean, if I say that I want only non-vegetated areas, it means that 100% there are no other stuff there.
Of course not.
Okay.
It has many issues, and especially we are working very much with environmental and agricultural objects. So we have the problems of clouds, of course, in optical data. Does Sentinel, the software that I mentioned, which generates this mask, does not perform well with identifying clouds and shadows. That's why we use more or less this software as a validation tool and not just a tool that we strongly and that we are confident 100% that it reveals what a pixel represents. That's why in other pipelines, we try to blend Sentinel with other cloud masking and atmospheric correction softwares, such as the Maya or the F-mask and things like that. And we also have implemented some smart ways to identify clouds, which is the basic problem that we have to tackle in the optical.
Okay. Thank you so much, Anasis.
You are very welcome.
I have a question related to Stelios' question as well. Do you have any idea what is the percentage of, let's say, for example, the vegetation inside one pixel to say that this pixel is vegetation? I mean, what is the threshold? Let's say, is it 80%? If we have 80% of vegetation within this pixel, we'll say that this pixel is vegetation, or what is like the threshold, please?
Okay, I understood. I don't remember the thresholding based on the given label, but if you go to the ESA's site, there's the whole algorithm and how it decides. It uses also NDVI and some other indices and pre-trained data in order to extract the final result. You can find it there, or I can send you the link if you want, in order to see how it decides on the class that assigns to each pixel.
Yes, it's gonna be useful for me. Thank you so much.
Okay. You're very welcome. So let's go back to where we are. Here, I have some examples. I will skip it because I will show you later on how we work with massive data, because here I only use the function in order to process one product. But if I want to process many products, I am going here, and I make a loop over each month in order to pre-process all this product here. I mean, we have here 5 products, and we are going to process all of them. And if we had all the months of a year, it would process all the months of a year. Now, just as a proof of concept, we process the second month of the year. So we are going back here, and we say for every month, pre-process every product that is in there. So if I run the code, it's starting to pre-process and generate the .geotiff products. Let's go to see what's happening back in the new folder that I said before. We have two folders, the initial data and the process data. You can change all this terminology or structure based on your needs, but for this workshop, I have these two. And if I go inside, you can see that now, except from the month, before we end up to the month and then to the products, but now, except from the month, it has created a new folder, which is the day. So this is the 22 of February. And if I go inside, you can see that it generates automatically all the new products in TIFF. This is GeoTIFF format. Okay, you can see that the size varies here because digital has as a drawback that cannot make a good compression of the data. So you can see that the initial B8 was approximately 8090 to the previous format JP2, but now it has increased to 164. Okay, for the other bands, which is not to 20 meters, the compression is better, and you can see that you have lower amount of size. So now you can see that we have created these files. I can load one of them. Let's load the TCR to the QGIS to see that everything is okay. Full of cloud, okay. But here is the final. And then as data scientists or developers, you can load these GeoTIFFs, you can upload it to a GeoServer, you can read their data and make data analysis, you can create web apps based on these cloud optimized GeoTIFFs. Okay, this is very friendly to all the applications. Of course, we have the SCL. Okay, this is the scene classification mask in order to use it to create cloud masks or whatever you like. And if I go back, you can see that here is a second. We will have 5 dates here because we had 5 products in the same month. It has started to. So sit tight and enjoy the rest of the process. I will not stick here and will continue. And except from the processing of the given bands, then you can make something else. We can create indices, for example, the NDVI index or any index you like. So now I will, sorry, let me get this link here. Sorry for the hard code, but in order to not changing the parameters above, I want to show you how the generation of indices takes place. But in order to execute this part of code, let's wait this one to be completed. And then until then, I will go and see you how in the backend we create the NDVI. This is based on GDAL, of course. Here we open the image, and we, if it's a multi-band, then you can choose band 1, band 2, or band 3, band 4. If it is a stacked image of many bands, here we choose only the first one because it has only one band. In order to create the NDVI, we need band 8 and band 4 for the Sentinel-2 mission. Okay, it's the near infrared and the red band. So we open the layers and we read their data. Okay, we read their data, we convert it to a very common Python format, which is NumPy arrays, and then this is perhaps strange to you, but those who have worked before with code and Python code, it may seems easy. For the other one, it may be not easy. That's why we hide it and we put it in the backend. But I want to show this to you because you can use the similar commands to create any index you want. For example, here I open the red band and the near infrared band, and I'm using, if you go here, you can see that I use the formula of NDVI, which is near infrared minus the red band divided by the sum of these two. And this is the formula for the NDVI. So in the same way, you can copy paste this function and change only the bands you are opening, and change also the formula here in order to create whatever you want, any index, any vegetation index you want. Of course, we can help you with this one if you have any problems. But I wanted to highlight how easy it is to create such an index. It still goes on. I will probably kill it, or if we have, no, it's in the last product, so I won't kill it. Let's see what is happening here. It will complete it in a while.
He says you wait, can I ask you a question?
Yes, this is a good time now.
Yes, recently you showed us the create NDVI function. When you create the formula of NDVI here, you say comma minus the big number. This is the node data value that you put.
Exactly. This is
Okay.
a detail, and I'm happy to know for you to know it. It's the node data value. This means that when you have node data in certain points, or the red and the near infrared is 0, it has to fill in with a specific value. So it's very frequent to use this value. And another detail here is the multiplication by 1000. Why I'm doing here? Because the NDVI is starting from -1 to 1. Okay, so it's a decimal number. It can be 0.2, but here I'm trying to multiply by 1000 in order to create a different time range with integer numbers, in order to reduce the memory size of the GeoTIFF. That's why I save it as an integer int in format here, and not as a float, as a decimal format. This reduces the storage that the GeoTIFF needs.
Okay, what I wanted to ask is that as you put this node data value, it wouldn't be optimized if we use the none value instead of minus 9000 and stuff, or it's worse for our GeoTIFF?
No, you can use it, but they are different. We not only use NumPys, we also use XArrays and rasterion, things like that. So we have a common guide that a best practice that says put everywhere the -999 in order when we exchange codes and try different libraries to be the same, because some of them does not accept the none value inside of them.
Okay, thank you so much.
You're very welcome. Let's go back to see. So finally, it has been ended. And now I am using the final cell in order to create our index. Cross fingers. Okay, this is a print that I may have put somewhere. As you can see, it's still running. There is no error. This is just a warning that it's going to divide maybe with 0, but NumPy can handle this, so there's no problem. And then, oh, no space left on device. So I didn't expect this error, but let's go back and see to the one that has been completed. It's 22. If it has generate the NDVI. Yes, here is NDVI, and you can see that I have set the name NDVI underscore index, and right now I'm going to this is due the rendering, so I can change this one to and this is the NDVI. Of course, you can color it here, and you will have the color palette that it's very frequent when we see things about NDVI. Okay, this is NDVI value, not from -1 to 1, but minus 1000 to 1000, but in integer format, not in decimal, not in float format. So let me delete some files in order to have space left. Goodbye, great. And this is the whole pipeline for the Sentinel-2 pre-process. We have completed this task. So if you have any questions now regarding the Sentinel-2 pre-process, it's a good time to discuss about them. Otherwise, I will move on to the Sentinel-1, which we have no only 15 minutes, but regarding the time, Sentinel-1 pre-process is a heavier, let's say, pipeline because it uses, as I said before, the Snap software, and Snap software is not so efficient when it runs via Python. So I don't know if we have time to check, but let's see. First of all, the pipeline. The pipeline is more sophisticated here because generally the SAR products need more calibration, need more pre-processing steps. So I'm not an expert on SAR, but based on the bibliography, we have created a pipeline that consists of the radiometric calibration. This is important in order to create the sigma 0 product, which is used in order to the products of different incident angles to be blended and used together. This is the idea. Because the SAR product comes with different angles and different levels of brightness. This radiometric calibration tries to smooth this difference in order to make these geometries comparable to each other. This is the idea of the radiometric calibration. I repeat, I'm not an expert, but this is based on colleagues here and the bibliography, the steps that we are following for this pre-processing. The spell filtering is a dedicated filter in order to eliminate noise that comes from scatters, for example, buildings and things like that, trees and things like that. So we use the refined leaf filter, which is, as they say, a very good filter. And then there is the terrain corrections in order to produce a better representation, a better geometric representation of the image. Okay, that is too close to the real world. This is the idea. And here we have used the range Doppler, the terrain correction. So based on these steps, we again use some parameters, the orbit and the year. If you want to clip the image, to a certain bounding box. This clip process can also be added to the previous pipeline for the Sentinel-2. It's worth mentioning here that the clip process, it's better to be done on the final step to make all the pre-process steps and then clip the image, because if you clip the image some step before, you may lose some important information on the calculation. That's why we recommend the clipping process to be on the final step. And a tip here, we have a separate file which is called grd.py, and it generates backscatters. This is the pre-process that I was talking about before. But why don't we, as you can see here, we do not import this file, the function of this file, but we use a command, this command, to execute differently this file, not to import the function for each file executed here, but to trigger to execute this file out of our file. Why this is happening? Because Snap has a problem with the memory. There is a memory leak. When you execute some functions, if the file does not close, it keeps the memory full of the previous calculations. So in order to avoid these things, you try to trigger an external file to make the job done and then go back to your file. This is the idea. Trigger the grd.py, finish the job, complete the job, and then go back here. This is a way to avoid this memory leak that is related to the Snap software. And if you are asking yourself why you have not going to some other software, there are not many other softwares, and especially so good as Snap. Snapista, a new software, is on progress. We are on progress of testing now this kind of library, a new library. So we may change it, we may update our pipelines based on Snapista if we see that is a good fit for our needs. So if I run this file, you can see that the pre-process is been starting here. And if we go, I think that I have not changed the directory, so it writes in the initial data. Let's see, yes, I have not changed the directory, so the generated products are not in the process data, inside the data. I forgot to change this path. So you can see that gradually it generates the V8s and the VV products, backscatter products for from our initial file. The size of the file here is bigger than the Sentinel-2. Generally, Sentinel have bigger size compared to the Sentinel-1, and I think approximately 1.6, 1.7 would be the total size of this file. For every product, we have two bands here, the V8s and the VV. 1.2, okay, and if I put it inside the GIS, okay, you see some values regarding, and here is a cycles, okay, some values. Of course, you can clip it in order to reduce the size of the file and to load faster the values of the image. Especially here where we can see C, we can clip it to a bounding box. Let's go back here. So there is no much parameters here to change, only the basic path where the data are stored, the orbit number, and the year of these two parameters are related to the directory that we are looking for our data. the most important parameter is here, the clip. If you set this to true, you have to change if it is true. You have to open this file, the grd.py. Let me show you. grd.py, which has the code of the pre-processing for the Sentinel-1, and set the coordinates here again in the 4326 projection. Okay. Here you have, if the clip is true, I repeat, you have to set these parameters. That's all from my side. Of course, if you have any questions, do not hesitate to ask me now or later on with an email, or I don't know what else.